Hello everyone, dear authors and invited guests. Welcome to Technical Session 4B. Myself, Ayush Garg, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th World Conference on Smart Health in System Security and Sustainability, World S4, London, UK. The seventh edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 21st August 2023, and the virtual event is being held through Zoom today and tomorrow, that is 23rd and 24th August 2023. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have six presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10th minute, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us in the closing remarks. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chair of this session. Dr. Tanupriya Chaudhary has 10-year experience in teaching as well as in research. Currently, he is working as a professor at Symbiosis International University. His area of interest include human computing, soft computing, cloud computing, data mining, etc. He is holding a post of secretary in IETA. He is also holding his advisor position in Indo-UK Confederation of Science, Technology and Research Limited, London, UK, and International Association of Professional and Fellow Engineer, USA. Moving forward, Professor Jose is currently an associate professor at Nimbia University of Science and Technology. His research interests include multi-agent coordination, software architect, distributed systems, big data infrastructure, and artificial intelligence. I welcome you both to this conference. I request if you want to introduce yourself for 1 minute, you both are open to do so.
Thank you, Ayush, for a nice introduction. I think we may go ahead with the presentations, please. And all the
Okay.
best to our presenters. Thank you.
Firstly, I would like to call Mr. Pramod Tripathi to present his paper on a novel secure approach for enhanced accuracy of force detection with private federate learning using TPSGD. You may please start your presentation.
Am I audible?
Yes, you are audible now.
Okay. Let me share my presentation. Then I'll continue. Okay. So good afternoon, everyone. The paper that I'm going to present is just a moment. My screen is little stuck. Okay. The paper that I'm going to present is a novel secure approach for enhancing accuracy of pest detection with private federated learning using DPSGD. Myself, Pramod Tripathi, and I'm associated with the Government Polytechnic, Gandhinagar. The other co-authors are A. Jani, N.K. Chaube, Ishan Panchal, and Shruti Agnik. And the agenda, the outline of my presentation is I will be introducing, then I will be telling about little background about the topic, the proposed architecture, the data set details that we have used, the implementational details, results. I will be concluding then and mentioning about the future work that we are going to do and the references. So starting with introduction, we have used federated learning as a term. So what exactly is federated learning? Machine learning and deep learning models are attributed to success due to their tight conjunction with larger user data sets. So they have large data sets, and that is the reason for their success. However, maintaining end user data privacy should be the highest priority. For learning, user for learning only they have to share the data, and the issue is for maintaining the data privacy, the data should not be shared. So there are various data anonymization techniques that are used to achieve data privacy. Unfortunately, user data can also be recreated even though the data anonymization techniques are applied. So we have proposed a new approach of providing user data security uh, suggested, uh, and that is not to share the data, but just to share the model parameters. So there is a technique, federated learning, where the learning parameters are being shared to the central aggregator, and then central aggregator aggregates those learning parameters and do the learning, and then shares back the learned model to the local uh, machines. So central server aggregates learning parameters and send back the final learned model to the clients. So this is what the federated learning is. And however, when the learning parameters are shared with the clients, this also reveals the information about the original data set, and this results into another class of data privacy issue. So for removing that data privacy issue, we can solve such thing by introducing differential privacy, where the original data set will be introduced with a noise parameter, and then the parameters are being shared to the central server. So we have defined some of the objectives, and the objectives are: we demonstrate the effect of perturbed model on model accuracy. Then we will be improving the accuracy of differentially private models by new techniques, and we will be building a private federated learning model with DPGSD, which is expanded as differentially private SGD on a data set that we have selected, that is agricultural pest data set. So coming to the background, the two contributing algorithms that we have used for our method is the FedAVJ algorithm for federated learning, and DPGSD, which is differentially private stochastic gradient descent algorithm. What FedAVJ does is, it trains high quality model using relatively few rounds of communication. Initially, the model is randomly initialized on the central server, and after each round, the random set of clients are selected. Each client performs local gradient steps, and the server aggregates the received model parameters and distributed final model to the client. This is done by FedAVG. And for DPGSD, this algorithm modifies the mini batch stochastic optimization process to make it differentially private. Then it adds Gaussian noise that hides the largest possible gradient to achieve privacy of each data point of the batch. And for each data point of the sample, it computes its parameter gradient. If its norm is high, then the value of C is used. So the proposed architecture looks like this. We have the local federated learning models on the individual machine, as you can see, the lowest layer. And then the local FL model is converted into a differential private FL model. So we introduce noise factors and convert it into a differential FL model. And then we have the aggregation that is done on the central aggregator. Central aggregator combines the information received by the local models, and then find out what are the learning parameters and send it back to the local machines, and this we reiterate with this particular process. So the algorithm that we have proposed is the differentially private federated learning, which is a combination of FedAVG and DPGSD. So so basically what is happening is, the central server is getting the weights from the individual clients, and the weights are calculated by the client updated method. Client updated method, what it does, it introduces the noise, and then it returns its parameters along with the weight, and the weighted average is being taken at the central server. So this is the way the algorithm is working. The data set that we have chosen for for checking the method is the agriculture pest data. It is available on the Kaggle platform. So the little bit about the data is around 107 MB, and there are some pest files which are there. So there are files which are related to ants, bees, beetles, and so on. So there are various pest files which are available. So we have used this particular data to implement the method. In agricultural domain, if we have to detect the pest, we have to actually share the pest information to the central aggregator. So using our method, you don't need to share all those information for learning about, for detecting the pest information in future. What we have to do, we have to just implement the federated learning model. The local model will share the parameters to the central aggregator, and central aggregator will accumulate all the models and will send the final parameters. So no need to share the data. So this will be a secure approach. The simulation parameters that we have used are quite standard. The momentum, which is a parameter in the deep learning, it is kept as 0.9. Noise multiplier 0.1, batch size 0.1, learning rates are 0.1 and 0.01. Iteration that we have followed are 20, 15, 100 iterations, and the epo size is 10. So the steps, if I summarize, what the steps that we have followed is the main model performs the weighted average using the federated averaging algorithm, that is FedAVJ, on received model parameters and build the new model. The central aggregator distributes back the new weight parameters to the main model to all the nodes for further learning, and this process is repeated over and over to improve the performance of the main model. So the discussing about the results that we have received by running different set of simulations, the first result shows that without introducing noise, we can see the accuracy that has been achieved before running the first iteration is shown in the diagram. We have plotted accuracy, and these are the sample numbers. So there are 5 sample numbers which are shown in the graph. So we can see that the accuracy received by the individual model is quite high as compared to the merged main model before the first iteration. And if we talk about the accuracy after introducing the noise, you can see that the accuracy drops as we introduces the noise. Then what we have done, we have increases the number of iterations, and as we increase the number of iterations after the first iteration, the comparable accuracies are achieved in both by the individual model and the merged main model. So we are not compromising the accuracy by doing the merged method, even though including the security parameters. For the noise data, again, we have the similar type of accuracies that we have achieved for both main model and the merged main model. And we have, in this particular result, we have shown that the accuracy with respect to the iteration. So if we increase the iteration, in the very first iteration, the accuracy of the main model, the local models is quite high as compared to the central model. But as we increases the number of iterations, we can see that the accuracy of the noise model are comparable with the local models, and it is a secure form of learning by introducing the DPGSD algorithm. So this is what the results that we are getting by running the simulations. So the conclusions are, through empirical studies, it is visible that differentially private federated learning could help to protect client privacy with reasonable accuracy. And we have shown that carefully choosing the parameters could lead to the development of highly accurate optimized FL model. And we have run it on the test data set. In future, we are planning to develop a federated learning model by applying various other optimizers for non-IIT clients with data privacy. And in addition to that, we will be focusing on the secure multi-party computation protocol that may play a big role in the user data privacy. So this is all from my side. Here is the list of references that we have included in the paper. And thank you.
It's a very nice presentation, Pramodji.
Thank you.
I just want to know, for a curiosity, that what are the optimizers actually you have used?
So we are actually optimize the entire process by running the simulations of our entire algorithm. So we have implemented the entire process using the standard simulators of machine learning using Python. We
No,
have
no,
not
no. I am just
purposefully.
asking you, any functions you have specifically used for optimization?
No, we have exclusively not used any optimizational functions. We calling it as an optimized algorithm since we are trying to optimize the accuracy by running the simulation. So actually, this is an empirical method of getting the optimization.
Okay, and what are the accuracy parameters you have chosen?
The accuracy, we have varied the EPO size, the learning rates from 0.1 and so on. And we have also used data set combinations to get that particular accuracy.
Okay, thank you.
Actually, stochastic gradient itself is a optimizer in ML that we have used. So that could be called as an optimizer method.
Okay, okay, fine. Over to Ayush, please. And if there is any query from another session chair, you may go ahead, sir, please.
Mr. Josh, do you have any query?
No, not at the moment. Thank you. Hello, can you hear me?
Yeah, yes, audible.
He is not having any query right now. We can move to the next presentation, please, Ayush. Thank you.
Yes, sir. Now, moving forward, I would like to call Subodh Sibitso to present his paper on Aggregated Framework for Surveillance Camera Collaboration. You may please start your presentation.
Good afternoon. My name is Sibotso Kanakang, and the reference number for my paper is 255. The title of my article is Aggregated Framework for Surveillance Camera Collaboration, and my co-supervisors are Professor Chunlin and Dr. Onaifa. I'm from Tshwane University of Technology in South Africa. Okay, the outline of my presentation will be the introduction, the related work, the methodology, the experimental, and the conclusion. Okay, the paper that I've done, it actually addresses the gap that exists in the surveillance camera collaborations. And more especially in industries that involve crime monitoring, because the cameras and the surveillance are used in many industries, including monitoring. There is actually a high need for camera collaboration, but in particular, there is more need for surveillance cameras that collaborate with each other. Because sometimes when cameras don't collaborate with each other, when the object moves through, if it missed by one camera, then at least it can be captured by another camera to avoid cameras that are not collaborating. Then currently in most instances, you find that cameras are not collaborating each other, which results in redundancy and overlapping of cameras as well. So that results in lower detection accuracy. To address this, that's why I've done this paper of the aggregated approach. So the cameras will be using, they will have vision controllers so that they can be properly track the moving objects. Each camera will be equipped with a vision controller, which will enable it to tilt and turn in the direction of the target that is being tracked. The reinforcement learning is used so that the vision controllers can work properly. Okay, regarding related work, I've done a lot of research and I've went through other papers in the same field of camera collaboration. So I've just summarized I've went through many papers, but I've just summarized the main ones from my paper that I've went through. So on this one, Crandall, he was actually talking about the cooperating with machines, where he was using artificial intelligence and machine learning. Then this one is also used in surveillance camera monitoring. Then on this second paper, it's RT Collins. This one is algorithm for cooperative multi-sensor surveillance. The author here introduced an approach which projects the location of the object to the ground plane. Then a bit of the downside from this one is it's because it works properly in indoors, or if it works outdoors, it's only on proper structural features. And then on this third one, it's the reproducible evaluation of pelt, tilt, and zoom tracking. The multi-camera collaboration on this one cannot be tested properly because of limitation of model and scene. Okay, when we go into the methodology, the collaborative framework is designed whereby the cameras are working interactively with each other to detect and track objects. The cameras are equipped with, as I mentioned, the cameras are equipped with vision controllers. When a target moves away from the view field of one camera, it will be automatically tracked by the next camera. So reinforcement learning is also used, which is utilized to make the most effective use of the vision controller in each camera. So basically, vision control uses the feedback from vision sensor to control the motion of the camera and track the movement of objects. So this is in a nutshell, the process that will be followed in terms of tracking. So the first part will be image acquisition, which will go through to pre-processing, then it will go through to the object detection, then it will go to the actual tracking of the object, then the data association and the output generation. Okay, after the whole thing is done, because the footage that will be obtained, it will be coming from different cameras. So there will be video stitching that is involved, which is the process of combining the footage from different cameras to create a seamless and continuous video, which will be able to make sense as the final output. So in a nutshell, video stitching will involve the camera calibration. That's the steps that are involved in the video stitching itself. The camera calibration, where the cameras needs to be calibrated, the feature matching, the image warping, then the blending, and then the scene correction and the post-processing of the stitched video. Okay, in terms of the experimental part, I need to mention that I didn't use the actual proper cameras out there in the real world. So it was a visual machine which was running on a Linux, Ubuntu, and then it was used for training and simulation of the system. So this is done instead, as I mentioned, it's done instead of a real world environment because it will require a lot of hardware and it works out very, very expensive. So evaluate the quality of object tracking, the angle error between target direction and camera pose angle is used, which is basically this formula here. And then the operative results in terms of the experimental. Okay, what I've done here, I've compared the single view maximum accuracy with the single view minimum accuracy and the aerial position cameras. I've compared all these three together with this system. So the percentages, it shows that this one is 62, this one 67.85, this one 75%. So this one, it has multiple views, and the experimental was done with 4 views, which go the tracking goes to 89.4%. And then in terms of comparing different scenarios, if I put it like that. So the cameras, when they are strategically positioned, the coverage rate is high, the multi-agent reinforcement learning rate is high, the reward discount factor is also high when the cameras are strategically positioned to be able to track properly. So the cameras that are randomly positioned, because it will be randomly positioned in a proper manner, the coverage rate will be low, multi-agent RL rate will also be low, and the reward discount factor is also low. The narrow view angle cameras, it's moderate for all the 3 scenarios. And then the wide view cameras, it's high on coverage rate and multi-agent, but the discount, the reward discount factor is low. So that also shows that when the cameras are strategically positioned, as in our system, then it becomes high. Okay, and then in conclusion, what I can say is this method outperforms the traditional method of surveillance, because in traditional method of surveillance, in previously the cameras were just placed there. Sometimes they were looking at one object at the same time and all that. So this system outperforms the traditional method of surveillance cameras, whereby cameras are overlapping, and there's a lot of, obviously the traditional method involves a lot of manual intervention that is required in there. And then in this method, cameras use vision controllers, work collaboratively, and bring about meaningful footage that can be used in crime investigations, which is just amongst other things, because it can be used in many situations. So the resulting information can be used in many areas, including crime monitoring. And I thank you for listening to my presentation. Thanks.
No questions from my side. Thank you.
I have 1 or 2 questions.
Okay.
My first question is, so the video stitching, it's done offline, right?
That's correct.
So that means that you cannot use your system to track a live event. Am I correct?
Okay, let me put it like this. The system is used to track the live event, and then when the video footage from different cameras is obtained, then it will be done. The video stitching will be done offline, as you said. Yes.
But I mean, if you had a way of stitching the videos online, then you could be tracking, say, let's take a scenario, a criminal that you're tracking, right?
Yes.
You'll have to wait
Yes.
until you consolidate videos from different vision controllers before you do the stitching, right?
Okay, yeah. To answer your question, the video stitching is not manually done. So I can say there will be a bit of delay in terms of the video, in terms of the time from when the footage is captured to the time when the whole footage from different cameras is done. There will be a bit of delay because the video stitching will be done afterwards, but it's not, the video stitching is not done entirely manually. So that's correct. There will be a bit of delay because the video stitching still needs to happen afterwards.
Yeah, but what I wanted to understand is, it's once the
Yes.
scenes are finished that you do the stitching, you actually collate the different videos together and then you do the stitching, right?
That's correct.
Because you could be saying, any sequence that I capture from any camera, I'll be doing the live stitching so that I can track live. Do you see what I'm saying?
I see what you're saying. It's just that I understand you, but it's just that in my system, the footage from the 3 different cameras, after it's done, then the stitching will happen afterwards.
Okay. Second question,
Yes.
could you please shed some light on how the reinforcement learning is used actually to improve on the vision controller operation?
Okay, I have a situation whereby the reinforcement learning, there is a reward structure is used to enhance when the reinforcement learning is used. Basically what happens is the machine learning, as it happens, then it will focus on the algorithms and models that will happen, that will enable the system to make predictions, and then the decision will be based on the data that comes from the training of the system. I don't know
What
if
I'm simply trying to understand is this. You have a bunch of cameras, right? So is the reward system per vision controller, or is it global to all vision controllers? Do they share the reward, or is it for each vision controller? So whatever algorithm you use in your reinforcement learning, is each one collecting the reward individually or collectively?
the rewards are done collectively.
So one vision controller misbehaving can then penalize the rest of the system.
Yeah, because the whole aim is for the cameras not to end up working as if they are working individually. The whole aim is to make sure that they work as a collective.
But isn't it that as you structure the cameras, each one has an area to cover? So you know exactly which one is covering which angle already by setup, isn't it?
Yes, that's correct.
So each one, you'll know that which one is misbehaving and which one is behaving, so that you could properly reward the ones that are behaving correctly so that they keep covering the angles, and the ones that misbehaving will adjust its angle because it's receiving penalties instead of reward.
The reason I've done it like that is because in some situations there will be occlusions and the cameras will not be steady. So sometimes if there was an occlusion on one camera, then the next camera needs to capture that, which the neighboring camera has missed. The next camera in line.
Okay, thank you.
Thanks.
I'm done with my questions. Thank you.
Okay, thanks.
Moving forward, now I would like to welcome Seema to present her paper on an intelligent decision support system for the surgical phase, an approach based on machine learning.
Hello, everyone. Do you hear me?
Yes,
Good. Do you see my screen?
yes.
Okay, good. So, hello, everyone. I hope you are doing well. My name is Shaima Bouden. I have the honor and pleasure to present to you my work entitled An Intelligent Decision Support System for the Surgical Preoperative Phase, an approach based on machine learning. Our presentation will be linked as follows. we start with an introduction where we will address the context, the problem, and the objectives to be achieved. We will then discuss the notions relating to the surgical field. We will keep a small section on machine learning. Then we will start the two disciplines on which our approach is based, random forest and SVM. Our approach will be validated through a case study. Then we will discuss the results. And at the end, we close with a conclusion and perspective. The operating room is considered the fundamental pillar, at the same time, the crossroads of a wealth of different material, human, and logistical resources. Reliable management of any hospital structure begins with the preoperative phase. Artificial intelligence seems a promising way to meet these needs. Among the major problems in the surgical field, we have patient care. Optimizing its operation is priority for hospital managers. So the idea is how to develop an intelligent decision support system for the preoperative phase using machine learning models. Our main objective is to propose an intelligent decision support system for the preoperative phase in order to reduce patient risk, reliable and optimized operation of the operating room, all this by using machine learning models. Concerning the surgical field, we treat the different phases of surgery: preoperative, perioperative, and post-operative. So we start with the preoperative phase. Patient
Sorry,
assessment.
we only
Yes.
see in the title slide.
Excuse me?
We only see in the title slide. I'm only seeing the title slide.
The title slide,
Yes,
the surgical field.
it's only the first slide that I'm seeing. It's not moving.
Really? You are seeing only the first slide?
Yes.
I will stop sharing my screen and I will restart. What about now?
Keep going, then I'll tell you if it has changed.
I continue?
Maybe you should put it in presentation mode and then keep moving, and then I'll tell you if it's changing.
Yes, I'm moving. My screen is on presentation mode.
I'm only seeing the title slide, the title and your name. It's not, the slides are not changing as you're talking. Look, to avoid further delay, if other participants are seeing the slides moving, it doesn't have to be in presentation mode for me, but somehow it will be helpful if we can follow your discussion with the slides. So whichever mode works, that should be fine.
Excuse me, what should I do?
I said it's not mandatory that you move to presentation mode, so long as we can see the slides together with your discussion.
I continue my discussion.
I guess so.
Okay, I will continue. Concerning the surgical field, we treat the different phases of surgery: preoperative, perioperative, and postoperative. Concerning the preoperative phase, patient assessment, diagnostic examinations, and discussions on the risks and benefits of the intervention, physical and emotional preparation of the patient, as well as detailed planning of the operation. Concerning the preoperative phase, the progress of the surgical intervention with close coordination of the medical team, real-time decision making based on the conditions encountered during the operation. Concerning the post-operative phase, this is essential to monitor the patients, adapt the care, monitor the progress of healing, and provide rehabilitation, advice, and home care. This phase completes the preoperative phase and allows comprehensive and personalized care of the patient throughout his post-surgical recovery process. The main phase of the preoperative process can be summarized in the following figure. And our part of contribution is at the step preoperative analysis. Do you see the figure or no? The same problem?
I don't. I'm still stuck on the first slide. I
Excuse
don't
me,
know
ma'am.
about the rest.
Ma'am, kindly share your entire PPT in the chat section so that I will present on your behalf.
I didn't understand.
Ma'am, kindly send the PPT in the chat box.
Yes, I shared the entire screen. I will continue. Machine learning. It should be remembered that our approach is based on machine learning, which is a set of techniques that allow computers to learn from data. Among the main benefits of machine learning is faster decision making and improved accuracy. Machine learning applications are present in various sectors such as finance, marketing, health, etc. We can summarize the stages of machine learning by this figure. We start with data acquisition, then data pre-processing, feature extraction, data division, classification, model evaluation using metrics, model testing, and then model refinement. We have opted for the random forest and SVM models due to their exceptional efficiency in managing datasets with high dimensions. We believe that the use of two well-known models of machine learning and by undertaking a comparative study in terms of the results obtained by two models, this will give us more advantage in terms of reliability and precision. At this stage, we will reveal the main aspects of our approach. The general idea of our approach is to move towards an intelligent decision support system for the surgical preoperative phase based on machine learning for reliable and precise exploration and classification of patients' preoperative assessments while using preoperative predictive data. I shared the figure that illustrate the idea of our approach. We can consider our future system as being a black box equipped with the random forest and SVM models, and which receives the data sets relating to a large set of patients, and which outputs is the operating prediction of these patients. Case study. To demonstrate the feasibility of our approach according to the two models mentioned, as well as the establishment of a good comparative study between the two models, we will use a database approved by Examination Committee Seoul National University Hospital Institutional. Data collection was performed in accordance with the relevant guidelines and regulation of the Institute's Ethics Committee. We will ensure a pre-processing phase of the data set, the latter which will be generated later to validate our approach. For simplicity, we will take a small part of this database, which has been previously pre-processed to simulate our approach. We notice that each attribute has multiple values, which is why we will use a binary recursive partitioning algorithm to build each decision tree in our random forest. We need to discretize our continuous attributes by spending thresholds, and this to split the data into two binary groups. This will allow us to build a binary tree using discrete values of each attribute. We get the following results. In a random forest, the first tree is integrated using bagging, which is the random sampling of training data with the replacement to create multiple data sets. Each set is the same size as the original data set, but contains different cases due to replacement sampling. Then a decision tree is integrated for each set using a random subset of features, the number of which is specified by a hyperparameter called feature sampling. After generating several decision trees, the result is a set of decision trees, each of which is constituted using a different set of data and random subsets of the features. To make a prediction about a new instance, the prediction for each individual tree is computed and the final prediction is obtained through a majority vote. Concerning the SVM model, and in order to improve the visual understanding of the data by projecting the points in space of reduced dimensions, we will use a well-known dimensionally reducing techniques, the PCA technique. This makes it easier to identify structures and the relationships between points, leading to the best analysis and visualization results. Our approach can be summarized according to the steps as follow. Writing our SVM model, no matter what the nature of the problem is. Using the kernel function allows us to transform a nonlinear problem into a linear form, thus simplifying the movement of input data to a dimensional feature space superior as the transition from two-dimensional representation to three-dimensional form.
Sorry
Excuse me,
for
ma'am.
interrupt. Ma'am, there's a one suggestion for you. Can you please change your presentation by manually? You can change manually your presentation slides number.
Yes, I'm changing the presentation manually.
Okay, but
Uh,
ma'am, can you see in the bottom line there is there's three option, and you
yes,
can
plus
yeah, please select the last one option.
the last one
Yeah, this
is
last one, it's a full screen sharing option. Can you please change your presentations number?
yes, I'm changing manually.
Okay. And ma'am, is there okay for you? You can share me your. Yeah, ma'am, it's moving. Yeah, now it's moving.
But it's not sharing the all screen. I continue like this?
Yeah, yeah, it's perfect. You can
Okay.
go ahead like this.
Okay. So I repeat this slide or I continue?
Continue, ma'am.
Okay. Revision and discussion. The two models, random forest and SVM, have been validated through the previous datasets and in an environment dedicated to the artificial intelligence. The execution environment is Google Colab. The IDE is Spider. The Python version is 3.10. The libraries I use the Pandas, the NumPy for and the scikit-learn and Matplotlib for visualization of data in graphs. By conducting this comparative study between the random forest and the SVM, our objective was to determine which of these two models offered the best performance in terms of reliability and accuracy for preoperative decision support. The results of our experiments showed that the SVM has slightly better precision and accuracy than random forest in predicting preoperative outcomes. However, the random forest has also demonstrated strong performance, especially when it comes to its ability to handle complex datasets. In our study, we used the attribute feature importance specific to random forest models for the scikit-learn library. This attribute allows to automatically calculating the feature importance during the learning process. This feature is particularly useful for understanding which feature have the most influence on model predictions and can also help with feature selection if needed. An interesting idea that emerged is to combine the advantages of two models in a hybrid model. In this scenario, the first model based on the random forest could be used as a selection filter for the relevant attributes, taking into account the attributes considered important by the majority of the decision trees. So in conclusion, we presented a novel approach based on random forest and SVM models for intelligent preoperative decision support. We made a comparative study of the models demonstrating the reliability and the precision, emergence of the idea of a hybrid model combining the strength of random forest and SVM. We have shown the importance of the approach to improve the precision and reliability of surgical decisions. Future research directions include exploring the extension of the SVM model and application of deep learning to the pre-operative and post-operative phase. Here are the references of the work we used to develop our approach. And thank you for your attention. Any question?
No question from my side.
Let me try one question. So sorry, I could not follow the whole presentation because I only started seeing the slides towards the end. But you suggested that building a hybrid approach by picking the features from the random forest and then applying them to SVM. Have you considered using a method like an ensemble method to actually take advantage of the strength of both methods?
Our emergence of an idea hybrid is combine the strength of random forest model and SVM model using the feature importance specific attributes in Python to show the more attributes, the efficiency of the best attributes, and those attributes we are going to use them for SVM model.
But I believe that's different from ensemble, because if I understand your suggestion correctly, you will first run the random forest to pick the features of importance, and then only extract a data set or rearrange your data set based on those features and retrain the model using SVM, right?
Excuse me, can you repeat the question, please?
If I follow your idea correctly, it is
Yes.
first running random forest to identify the features of importance, and then based on those features, select them, rearrange the data set, and train the model following SVM, right?
No, our approach, in our approach, we are use the random forest and the SVM model, and we did a comparative study.
I understand that. I understand that. And then what I'm
Yes.
saying, I'm actually talking about your suggestion, the hybrid approach that you're suggesting.
The approach I'm suggesting?
Yes. Where first,
yeah,
where my understanding of that approach is that first you run the random forest to pick the features of importance, and then
Yes.
based on as if you're doing dimensionality reduction in a way, because you only focus on the features of importance dictated by the random forest. And only after that do you proceed with the SVM training the model. Am I correct?
We did SVM model and then SVM model, and
it's not what you did, it's what you are suggesting. How you want
if
to
I
do
tested the hybrid model?
Yes.
Not yet, but it's an interesting idea emerged.
Yes,
didn't.
I'm saying I'm following your suggestion, and I'm trying to get somewhere. So according to your suggestion, What you're trying to
Yeah.
do is, first of all, run the random forest, get the features of importance, and based on the features of importance, then train the SVM in the new hybrid approach that you're suggesting. Isn't that what you're suggesting?
Yes.
Why not consider an ensemble method from the get-go where you run both at once and they improve each other? Because such techniques exist already.
Which technique?
Ensemble techniques, where we can actually combine several training techniques and then train the model, and it will pick the strength of each method to improve your overall model. If you haven't looked at it, I suggest you look at it. Thank you. I don't have any other question. Have I missed anything?
Let's proceed further. I would like to start with the paper. Trina to present her paper on lecture-based practices for designing female inclusive software engineering and computer science program.
Hi, yeah, could you please stop demonstrating the screen? So I hope you can see my screen and hear me well.
Yes, ma'am.
Okay, good afternoon, everyone. My name is Ekaterina, and I would like to present you our research paper, which is called Literature-Based Practices for Designing Female Inclusive Software Engineering and Computer Science Program. And I would like to start with our motivation for this research. As you might know, despite the global steps taken toward gender equality, the low ratio of women in technology still exists. And even in the countries which are leaders in gender equality ratings. For example, in Finland, which is one of these countries and where I'm living and working right now, in 2020, only 7.5% of ICT graduates and 23% of ICT working specialists were women. And overall, in 2019, women represented less than 20% of population with qualifications both in ICT and engineering. So what's the problem? Researchers connect this phenomena with existing social norms and barriers and stereotypes. Women feel less confident in their technical abilities and skills, and they also receive less support from both educators and families, and therefore choose more female-dominated professions and try to avoid technical pathway. There are several solutions for these problems, and one of them is involvement of universities in making their environment more female-friendly and their programs more female-inclusive. And universities around the world were implementing these practices, and they were quite successful. For example, local interventions have doubled the percentage of women recruited to Bachelor of Software Development program in ITU in 1 year from 11% to 22%. So our goal was to collect the most common practices for achieving gender balance and attracting women to software engineering and computer science higher educational program. For this purpose, we used systematic literature review using keywords from three groups like gender keywords, educational keywords, software engineering, and computer science keywords. We collected 1,170 papers from 5 databases. After excluding duplicates and applying inclusion criteria, we received our sample of 49 papers. Our inclusion criteria were papers which are older, like 2000 from 2015 and later, in English, focusing on female experience or gender differences in higher education. For this study, we focused on computer science, software engineering, and ICT because often people use STEM, and this term includes science, technologies, engineering, and mathematics. However, some of the fields like biology, which is also included in STEM, is actually more female dominated. So it's not quite right to take such a broad perspective. So we narrowed down our focus to computer science, software engineering, and ICT. And what's the most important, we wanted to see practices which were already tested and proved to be efficient in tertiary education. So that was our inclusion criteria. And after analyzing this literature, the most important findings were that support is important. And as I already mentioned, women feel less confident in their computer science abilities. So universities should pay attention to making women feel comfortable. So non-biased advertising, gender talks, community building, preliminary training, and so on. These measures, they are helping women to increase their confidence and sense of belonging. More practice is needed. Studies recommend that more practical tasks and experience in learning processes may help students feel more confident in their skills if they apply their knowledge in practice. So industry visits, internships, or even practical cases in classes will help women to feel more comfortable. Outreach activities were found to be the most popular practice for attracting women to software engineering and computer science. This practice is needed to reach for reaching an audience that is not yet planning or is doubting to study computing, and it helps to encourage these potential applicants to choose this field. And also, it is important to use advanced technologies in learning process. Studies show that physical computing, 3D, virtual programming, robotics, they all increase interest of students, both men and women, in their studies. So we divided practices we found into 4 groups based on the responsibility level. So we have university level, program level, and course level. So in university level, the decisions are made by the university administratives. In the program level, it's more about department or program director. And in the course level, these decisions are made by lecturers and other teaching staff. And we also separated promotion because it works a little bit separately from others. And it is important that promotion delivers a message university want to deliver for potential applicants. And it is important also to work with promotion and marketing department. And under these levels, we identified certain initiatives that could be implemented So under promotion, we would like to emphasize outreach programs and non-stereotypical advertisements as a tool to attract more women. And the university level, we recommend gender talks and building community, such as female in tech clubs or some other initiatives that help women to feel not to feel lonely. Program level, on the program level, universities can provide mentoring or tutoring, preliminary training for those who are not confident with their background. Practice, as I already mentioned, it is important for students to feel confident, and mindset interventions helping students to understand that everything can be learned and it doesn't matter what is their background and what are their characteristics. And on the course level, as I already mentioned, it is important to use visualizations, some technologies like robotics, hands-on examples. It is also important to promote the social factor of computing and how it can support sustainability. And also in programming classes, programming also helps women to perform better during studies. As a conclusion, I want to say that gender inclusive initiatives, they require time and effort, and it's hard to evaluate the effect of these initiatives in short run and understand if they are working effectively. So this paper provides the initiatives that were already tested, and there are high chances that they will work. However, it is important to test these practices in different combinations within a specific social and cultural context, because we all know that it is that not everything works under different conditions, and social and cultural factors, they are important, and we need to test all these measures under different conditions. And that was all for me. Thank you for your attention. You can ask any questions or contact me or my colleagues later on.
Hi, this side Professor Tanupriya Chaudhary. Have you used any statistical measurement on your work?
No, this was a qualitative study. It was literature review. So here we didn't use any statistical measurements.
Okay, as you have done already on literature-based practices for designing female inclusive software engineering and computer science program, I think there must be some unique design you have made.
Which design?
Any graphical
you
abstract you have made?
No, we just listed all the measures which we have found as promising for attracting more women in these educational programs.
It's very fine, but try to include some figuric response also.
Okay,
as because your paper name is related to some designing aspect and all. That's all. Thank you.
Okay, yeah, thank you for your comment.
I don't have any question. Thank you.
Thank you.
Moving towards the last presentation, this conference, I would like to start with the paper S. Umarani to present her paper on parsing a generic streamlined intellectual parking system using ALPR and RFID.
I hope, can you visible my screen?
Yes, ma'am.
Thank you. My title is Park EC. It is an Android application. It is for a generic streamlined intellectual parking system using ALPR, or RFID. So presented by Dr. S. Umarani, co-author or V. Purnima, Dr. S. Gayatri Monica, Mr. Ashwin Chinnaya, and Mr. Karthik Rajan. This is the outline of my work: abstract, introduction, objective, scope, tech stack, overview, and future enhancement. So Park Easy introduced an innovative parking management system that cater to both carriage owner and consumer. The platform encompasses two Android applications with passport-based access for convenience. Consumer benefit from GPS-enabled map, real-time notification, and easy booking, while carriage holder enjoy dynamic spot update, ALPR technology, and IoT integration. An admin panel offers robust analytics and data export, aiding operational insight. This intelligent system streamlines parking, enhances user experience, and ensure efficient carriage operations, marking a significant advancement in parking management. The parking spot can be dynamically generated depend on the stakeholder requirement. Initially, it has no data. So this is small introduction about our problem. So Park Easy is a comprehensive parking management system that offer a user-friendly experience. It simplifies parking management and monitoring, a convenient and efficient solution for both owner and user. The objective of our work is to build with minimal hardware and cost-effective, time-consuming, hassle-free parking during slot booking. In built user-friendly app, it reduces user utilization time to create dynamic parking slot within a short time duration, which decreases the fuel consumption. With the help of navigation, the user can identify the nearest slot and park their vehicle during the peak hours. During the registration, the slot will be allotted based on the type of vehicle and the user for elderly parking. Exclusive e-vehicle parking with charging facility will be allotted during the booking. So this is our objective. And scope of project means this application can be adopted to any type of parking management system. So the main motto of this application is using less resources such as fuel, time, and spare to achieve faster, easier, reduce traffic, and increase the security. It is not only for the parking management system, and also can monitor facility also available in this work. It control in real time everything that happen in the car park in multiple levels: access control, subscriber management, transaction, billing, level of occupancy, and booking. So this is the following tech stack include for developing the Android application: Android app development using Java, Google Map API integration for location-based services, Firebase for authentication and real-time updates, then ALPR technology for vehicle identification. This is also API, data analytics, Excel export, and RFID. This is overview of our application. So as I told already, it has two type of application. One is owner application, another one is user application. This is for allocating parking space in efficient manner. It simplify parking management and monitoring, a convenient and efficient solution for the admin as well as the user applications. This application have no data initially. There are many different strategies for data collection, each with its own strength and weakness. Some common data collection strategy include web scrapping, API data collection, and sensor. Here, this work is used sensor and API data collection strategy. Unfortunately, the convenience of this approach comes at cost of flexibility and control. The ready-made data set are restricted from using the entire attribute from the data set. Chances are that some of the record or features that would have been useful to concern work that were discarded by the source. These sources of data certainly have their merit, but their limitation will add a constraint to any subsequent analysis or thereby decreasing its accuracy. The data can be collected or extracted directly from other entity with minimal code required. The data is stored in a cloud environment to accommodate increasing volume of data as the application utilize grow. This application is developed using a combination of RFID and ALPR technology. So, things that is RFID is low cost and low power technology for identifying item through 13.56 megahertz radio waves. The main drawback of using this is very small scope of radio coverage region. By using passive RFID and active RFID requires supply power to activate the tag. It is not feasible to implement in our work. The RFID utilized for the private user and the ALPR technology used for vehicle identification and also the private user. The wireless sensor network or wireless distributed network with no central control for monitoring node actions. The nodes in the network are connected through air media and can change location based on the need of the user. WSN with the camera is utilized at the entry and exit point. As well as parking spaces to assist in maintaining parking slot allocations. In earlier method, N sensor node were used to communicate a database server to update and reserve parking slot and validate the vehicle by performing the ALPR on each station and process the data in database server, whereas this system have used limited number of wireless sensor node for achieving the above. ALPR is a computer control camera system that are typically mounted on the street pole, street light or express.
Sorry to interrupt. Dear presenter, you are
Yes.
still on overview slide.
Yes, I am given overview only.
Okay.
So, ALPR computer control camera system that are typically mounted on street pole, street light, or express highway overpasses. It is a computer algorithm to automatically capture license plate information from vehicle through the camera or any other mobile device in digital parking space booking app. ALPR technology can be utilized to help user allocate available parking spaces with ease and efficiency. By scanning license plate of a parked vehicle, the app can quickly determine if a parking space is available or occupied and display this information in real time. Our app utilizes ALPR technology to automatically detect and read the license plate of parking car, eliminating the need for user to manually input their license plate number during the booking process. This is not only save the time but also minimize the risk of input error. With the ability to accurately identify license plate number, the ALPR technology enables a seamless and efficient parking experience. The data are collected through the application using GPS. So this first four screen is mainly used for the user app. So whenever first the user can create the login by using the registration page. After
Ma'am, sorry to
including,
interrupt you.
yes.
These all are a process and an application. Is there any specific algorithm you have used?
Yes, sir. So whenever creating the dynamic parking slot phrase, so it will be, we have used an algorithm for identifying the parking slot for the parking spot. So dynamically the
Have
spot
you
is
mentioned
created.
anywhere for this?
So this screen, sir. So whenever give the square feet value here, automatically it will be create the number of parking slot for based on the vehicle type. It may be a two-wheeler or four-wheeler
Yes,
based
ma'am.
on
I
that.
think right now you are on the
And
8th
this
slide
is,
and you
yes,
might be having 30 number of slides.
yes, I am moving
Okay,
next.
okay, but try to mention the algorithm also in a writing
Yes,
format. It's very good that you have chosen picturally, but try to add that point also. On the
okay.
right hand side, you may add that letter. Thank you.
Okay, sir. Thank you. So this is one more algorithm is used in this portion also for allotting the parking slot using the sensor radar technology. So this is an owner app. So whenever using this owner app is helping for slot allocation based on the free space. This were proposed efficient allocation of a parking slot for the user with the minimum time. The type of user can define as a private user, public user, and owned user. The parking place or organization, campus, or any public sector has different entry as well as the different exit. So this is the main advantage of using this owner app. It accepts different entry as well as the different exit. So based on that entry and exit, it will allocate the parking slot for the user. The next one is identification of the registered user or new user, tracking of unattended vehicle by notification. Total slot will be derived based on driveway space as well as the parking model. So this is in this screen is mainly used for identifying the parking slot. Depends upon the area size as well as the vehicle type of the vehicle, and automatically the dynamic slot is added in the app. Initially there is no occupation available, that is also mentioned here. Then available slot also here based on that user request, it will be allocated the parking slot. And pre-booking also supported in this system. So this is owner app. In user app, so for first the GPS, the location is user location is identified based on GPS map location. So here we have mentioned three options. One is map, another one is nearby location. So finding the nearby location, we have applied an algorithm. So based on this entry, it will be identify the nearby
Excuse me, ma'am.
parking yes.
I apologize for the interruption, but would you kindly consider concluding your presentation as we have only 1 minute left?
Okay, thank you. Okay, then user can book the parking slot through this option. And if you want to take the user information, also mention here. And according to the allocation of parking space, so it will give the report like that. In admin panel, you can able to take overview of parking lot activity, analytical reporting, and vehicle details. It is possible to identify any type of vehicle, including those driven by employee, student, or public transport vehicle, based on tag to avoid unwanted vehicle parking and non-designated parking spot. Export vehicle detail as Excel sheet for efficient data management. Then this is admin panel using the ALPR technique. As I told already, consider the user as a public user. In every entrance, keep camera or mobile phone, capture the image of the vehicle and extract the vehicle number from the image using ALPR. The captured image are stored in cloud, and vehicle information and basic user informations are maintained in Firebase database. So through the mobile, we can able to take the photo of the vehicle, and from this photo we extract the vehicle number. The vehicle number is stored into the Firebase database. The entire image and number are stored into the ALPR database. So in our admin panel, if you want to take any analytical report for the process, you can able to take this export vehicle detail as Excel sheet for efficient record maintenance of in and out vehicles. So parking slot management support for dynamic and automatic update. Notifications are being sent to leftover vehicle to prevent them from stopping overnight without authorization. ALPR technology or RFID tag seamless entry and exit process. Identification of parking slot to detect the presence of parking vehicle using wireless radar technology. The parking lot status can be identified through a light red or green, as well as the vacant position of slot. Distributed WSN concept is implemented to communicate database server to update and reserve parking slot. So how the parking slot is allocated mentioned here. The information can be transferred over the distributed WSN. Future enhancement, a queue model will be generated for finding parking time, which helps to reduce the crowd during their parking. Kafka framework will be used to decrease the booking time of the user. So this is all the points we have identified for future enhancement of our applications. Thank you.
I have asked a question. Thank you.
Mr. Josh, would you like to ask any question?
No, sorry. I don't have any question. Thank you.
Okay. I sincerely thank our author for their excellent presentation contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the seventh version, all the previous six versions of the conference. We will be happy to have you in the eighth version in 2024. All the presenter would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of World S4 2023. Would you be so kind as to offer some remarks, dear Professor Tanupriya Chaudhary and Josh, to enrich our session?
Okay, then I can go very briefly. I just want to thank all the participants, all the speakers, and the organizers. Thank you very much.
Thank you, sir. I also thank our session chair, Professor Tanupriya Chaudhary, and Professor Josh for chairing the session, a token of appreciation to the chair on behalf of Team World S4 2023 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Dear all, I kindly request you all to switch on your camera for a quick snapshot of the virtual conference. Thank you so much.